All right, I thought I would just make a nice, quick supplemental video about density because it's something we'll be using in class as we're practicing measurements, and I want to make sure you understand what density is. Okay, so density, we're looking at how much stuff occupies a certain amount of space, and the important thing to know about density does not depend on the size of the object. So a bigger object is not necessarily more dense than a smaller object just because it's bigger. Because as you get bigger, like let's say if I have a small piece of aluminum versus a big piece of aluminum, as you get bigger, you also have more mass. So both your volume and your mass increase, and they increase proportionally. So you can kind of think about, here's a way to visualize density. If we're looking at like which objects have the same mass, in terms of which ones have the same number of circles. So these two objects have the same mass because they both have 4 circles. And these two objects have the same mass because they both have 20 circles. If we're looking at which objects have the same volume, okay, these two objects have the same volume which is being represented by the area. And these two objects have the same volume represented by area. If you look at which two objects have the same density, okay, actually only 2 of these have the same density, okay. These objects here have the same density, so the circles are packed similarly between them, and so that's how we're representing density. So this one over here has a very low density, and this object here has a very high density, okay, just because they're packed in so close. When we calculate density, there's a couple of different ways to do it. And I really got to get my density music video back on, so maybe I should work on that today. But anyways, for now, density equals mass divided by volume. So someday you'll get to watch the video and I'll just be like, it's mass over volume, all right. Okay, so, but that's density's formula, mass over volume. To help you remember density's formula, you can just remember how much you love density. So we've got this heart here, and I suppose really since it's a heart, I should probably make it red. Whoops, that's not quite what I wanted to do. Now you can't see the heart. Okay, there we go. So we got a heart there, and you got a line through it because maybe you don't like density that much, or maybe you fell out of love with density. So when you take your heart and you draw a line through it, you got an M on the top and a V on the bottom, so that's how you can remember your mass over volume. Or when you're calculating with density, you could use this hyperintelligent triangle. So you arrange your triangle where you put mass at the top and density in the volume in the downstairs. And then depending on what you're trying to calculate, so if you're bad at algebra, this triangle is actually very good at algebra. So let's say I want to know what the density is. I cover up the D, and it brings me back to my very familiar formula that D is mass over volume. Let's say if I want to know what the mass of something is, I cover up mass, and mass is density times volume. Let's say I want to know what the volume of something is, I cover up V, and volume is mass divided by density. So if algebra is not your thing, just ask the friendly triangle. It's always willing to help. Okay, so going to some example problems here. If I have a block and it's 3 by 4 by 2 centimeters, and it has a mass of 48 grams, what is its density? So when I go to do this problem, so density, remember, is mass divided by volume. So I have a mass of 48 grams. Okay, so here's my mass here. But you're like, well, I don't have a volume. Well, volume is length times width times height. So I take my 3 times 4 times 2. So 3 times 4 is 12 times 2 is 24. And my handwriting is going to be really bad because I'm just using the trackpad on my laptop to do this one. So I've got 24, and since I multiplied 3 length units together, I have volume units of 24 centimeters cubed. And then to find my density, I take my, this is like harder than you'd think it would be. I take my 48 grams here, so that's supposed to be a G, and I divide that by my 24 centimeters cubed, and rather than writing that again, I'm just going to drag that on over. So I got 48 grams divided by 24 centimeters cubed. So if I look at, okay, so what does that equal? Well, 48, again, got to do my numbers and my units separately. 48 divided by 24 is 2. And grams divided by centimeter cubed, well, nothing in that unit cancels out. So that's still grams per centimeter cubed. Boy, and you thought my handwriting was bad when I was just writing normal. Okay, so if I look at the next one, a piece of gold has a density of 19 grams per centimeter cubed and has a mass of 57 grams. What is its volume? So again, you can go back to the triangle and you say with my triangle, all right, triangle, I'm bad at algebra, so I'm looking for volume. So it says just take mass divided by density. So I would go back, whoops, wrong way, and I'd say, well, I got a mass of 57 and a density of 19 grams per centimeter cubed. So I take 57 divided by 19, all right, and that will give me, I think, 3 would be up 3, and then the units would be centimeters cubed because grams cancel out grams. So see if you can get that to work out. And this last one here, check that one too, and then come and check with me and see like, hey, Mr. Keogh, did I do that right? All right, so that's all the extra stuff I wanted to show you about density.